Welcome everyone. We are discussing limit. Through this video, I am going to discuss some miscellaneous problem of limit. Look, problem number 1. Alpha beta roots of the equation ax square plus bx plus c equals to 0. Then limit extends to alpha, not infinity. 1 minus cos ax square plus bx plus c by x minus alpha whole square equals to what? So, ax square plus bx plus c equals to 0. Roots are alpha beta. We know this one. Alpha beta equals to c by a. So, we know ax square plus bx plus c. This is equivalent to, look, if we take x common, b by a into x into c by a. So, a into x square, alpha plus beta into x plus alpha beta. So, you can write it directly. This is well-known result. Ax square plus bx plus c, a common x minus alpha into x minus beta. Now, we consider the limit. Limit x tends to alpha. This is alpha. 1 minus cos, this is a, x minus alpha, x minus beta by x minus alpha whole square. This is argument of cos. Now we can use L'Hospital rule, but argument is x minus alpha into x minus beta. So try to avoid L'Hospital rule. So limit x tends to alpha. 2 sine square a into x minus alpha x minus beta by 2 by x minus alpha whole square. Now sin x by x standard limit. So we want to express it. Look to this form, sin a into x minus alpha x minus beta by 2. This is argument. So as x tends to alpha, this argument tends to 0. So make it balance by these 2. Now take whole square. Take this as whole square, product of this. Now what we have to balance? X minus alpha whole square. This is balance. But here a square into x minus beta whole square by 2 square, that is 4. You have to balance. Now look, this one is x tends to alpha. So this is sin x by x whole square. So this one is 1. So 2 into, if we put x equals to alpha, a square into alpha minus beta whole square by 4. So finally, a square by 2 alpha minus beta whole square. So we have already discussed. So this is whole square and argument is not single one. That is why we are avoiding L'Hospital rule. So what is answer? Answer is a square by alpha minus beta by 2 whole square. So using properties of roots of quadratic equation, we can simplify this one. Now second problem. So this and this exactly same. So 1 minus cos, this is power is x to the power 4. So not simple if we use L'Hospital. So power is x to the power 4. So avoid L'Hospital rule. X tends to 0. So 1 minus cos 2 sine square x by 2 by x to the power 4. Then again use formula 1 minus cos x 2 sine square x by 2, 2 sine square x by 2 by 2. So 2 cancel by x to the power 4. Now 2 outside, limit x tends to 0. Sine square x by 2 by sine square x by 2 total whole square. Now look, so whole square, so sine square x by 2, this is balance. So we have taken this as extra. So this is sine to the power 4 x by 2 and x to the power 4 is balance. Now look, as x tends to 0, this argument x by 2 sine square x by 2 is 0. So by standard limit, this is 1 square. Now again you use standard limit. Sine x by 2 by x by 2 whole to the power 4. So this one is balanced, x to the power 4 is balanced, and it is only to be balanced by 1 by 2 to the power 4. So answer is 1 by 8. 2 into 2 to the power 1 by 2 to the power 4. So 1 by 8. So here this is of 4th degree. So try to avoid L'Hospital rule. Next, limit x tends to minus infinity, x to the power 4 sine 1 by x minus x square 1 plus mod x whole cube. Now x is negative, so mod x, so limit x tends to, this is minus infinity. So x to the power 4 sine 1 by x minus x square 1 minus x cube. So mod x minus x. Now you put a transformation. X equals to 1 by y. As x tends to minus infinity, y tends to 0 minus. Negative but very, very small. So now we try to express the given problem in terms of new variable y. So limit y tends to 0 minus 1 by y cube, 1 by y to the power 4 sine y, 1 by y square. Now simplify. So this is sine y minus y square by 1 y cube minus 1 into 1 by y into 1 by y to the power 4, this. Now look, as y tends to 0, y cube minus 1, this one is defined, finite. So we write it in this form. Y tends to 0 minus 1 by y cube minus 1 into limit y tends to 0. So if you divide it by y, so it is sine y by y minus y. So this is 1 by 0 minus 1. This is 1 minus 0. So minus 1. Value is minus 1. So what is value of the limit? Value is minus 1. Now we try to solve problem number 10, 15 and 14. Problem number 10. It is most important problem. Actually it is problem of function. So look, a relation is given 2f sin x root 2f cos x equals to tan x. So from this relation we have to find fx because limit 1 minus x fx. So look, we have solved this type of problem. 3 f of 1 by x equals to x. Suppose this is a functional relation. Find fx. So what is our rule? We replace x by 1 by x so that we get this function. Here it is 1 by x, it is fx. And solving we get fx. So we replace x so that we get same function. Here fx and f1 by x. So two functions, f argument is x, f argument is 1 by x. So if we replace x by 1 by x, so here we are getting this and this is 3fx. This is 1 by x. So solving we get fx. So this is our main idea. Now this is sin x and this is cos x. So x to be replaced by pi by 2 minus x because sin pi by 2 minus x is cos x. So replacing x by pi by 2 minus x. So we get 2f cos x, omitting one step, root 2f sin x. This is cot x. So this is 2. Now our main aim is to find fx. So f root 2f cos x. This is 2f cos x. So try to cancel f of cos x. So this to be multiplied by root 2. So if we multiply this by root 2, so we get 2 root 2 f sin x. 2 root 2 f sin x. This is 2f cos x. And this is root 2 tan x. This is 3. Now if we subtract, so what we are getting? Minus root 2 into f of sin x equals to cot x minus root 2 tan x. So f of sin x equals to 1 by root 2 minus 1 by root 2 cot x plus tan x. So this is f sin x. Now our main aim is to find fx. So this sin x will be x if we replace x by sin inverse x. So we get fx. Sin of sin inverse x is x. Tan sin inverse x minus 1 by root 2 cot sin inverse x. So this is form of fx. Now look, from inverse circular function, argument, see sin inverse x as theta. If we take this as theta, so what is sin theta? Sin theta is x. So this is x, this is 1. This is 1 minus x square. So what is tan x? tan theta, what is tan theta? X by root under 1 minus x square. And this is minus 1 by root 2 cot base by this. So root over 1 minus x square by x. So this one is fx. So this is actually problem of function. So now find limiting value. Limit x tends to 1 root over 1 minus x into fx. So limit x tends to 1 root over 1 minus x. So x by root over 1 minus x root over 1 plus x minus 1 by root 2. This is x root under 1 minus x square. So limit x tends to 1. So we are getting x by root under 1 plus x. This cancel. Minus 1 by root 2. This is x. And root over 1 minus x square into root over 1 minus x. So x tends to 1. So 1 by root over 1 plus 1. This is 1, numerator is 0, so 1 by root 2. So this is 1 by root 2 and this one numerator is 0, but denominator is non-zero. So what is value of the limit? Value of the limit is 1 by root 2. So actually it is functional relation. From functional relation we have to find fx, then find limit. Next, problem number 15. So this is simple problem. So this is familiar problem. In derivative, we can find its derivative ddx of this. We can find limit of the function. So look, limit x tends to infinity, this one. So if we multiply by 1 minus x, this is 1 minus x square. Now we are getting second term as 1 plus x square. So if we take only 1 minus x to numerator and denominator, then it is 1 minus x square. Then limit x tends to infinity. Look, again you are getting 1 minus x to the power 4, 1 plus x to the power 4. You are getting formula in each case. Then 1 plus x to the power 8, 1 plus x to the power 12 by 1 minus x. The next step, 1 minus x to the power 8, 1 plus x to the power 8. Then we have to use induction method. So if it is 1 minus x to 1 plus x to the power 8, so previous is 1 minus x to the power 8. So proceeding in this way, we get limit x tends to infinity. 1 minus x to the power 2n, and this is 1 plus x to the power 2n by 1 minus x. So limit x tends to infinity, 1 minus x, 1 minus x to the power 4n. Now look, one restriction is given. We have already discussed it in previous class. If minus 1 lies between plus 1, if x lies between minus 1 to plus 1, then x to the power n tends to 0 when n is very large. And number 2, if x greater than 1, x to the power n tends to 0, tends to infinity when n tends to infinity. So mod x less than 1, that is minus 1 to plus 1. So using this result, so we get 1 minus 0, so this is 0 and this is also 1 minus x. So look, this is n tends to infinity, sorry, this n, this one is n. N tends to infinity, not x. So x to the power n tends to 0. So x to the power 4n tends to 0. So 1 by 1 minus x. So this restriction is important. So this is also very simple problem. Now problem number 14. This is problem of Wbjee board problems. So look, limit x tends to pi. So rationalize it. 2 plus cos x minus 1 pi minus x whole square root over 2 plus cos x plus 1. You know, rationalizing factor, this creates no problem. So you write this part, this is a rationalizing part. So this limit x tends to pi. And what is the second part? 1 plus cos x by pi minus x whole square. This is board problems of Wbjee also. So put x equals to pi. So cos pi, this is minus 1. And for the second one, pi minus x equals to y. So as x tends to pi, y tends to 0. So what is x? Pi minus y. So limit y tends to 0. This is y square. 1 plus cos pi minus y. Cos pi minus y. So cos pi is minus 1. So this is root over 1, 2. And this is limit y tends to 0. 1 minus cos y by y square. So this is well known limit, half. So answer is 1 by 4. This is of Wbjee 1 or 2 marks problem. And now we consider problem number 16, 17, 18. So problem number 16. So this is same that of previous one. Rationalization. So limit x tends to 0. This is 2 cos x plus 7 minus 9. And if we factorize it, we get this is 1 minus 3 to the power x, 4 to the power x, 4 to the power x, 3 to the power x. And rationalizing factor is 2 cos x plus 7 plus 3. Now we know rationalizing factor, this creates no problem. Limit x tends to 0. So 2 cos x plus 7 plus 3. Make it separate. And this is limit x tends to 0. 2 into cos x minus 1. And this is 4 to the power x common. So 3 to the power x minus 1. So 4 to the power x minus 1, 3 to the power x minus 1. This one. So if we put x equals to 0, so this is 9 root over 9. So 3 plus 3. and this one is 2, and limit x tends to 0. This is 1 minus cos x. 4 to the power x minus 1, 3 to the power x minus 1, and minus 1. Now standard, this is well-known limit, 1 minus cos x by x square. So this is 3, so minus 3. So limit x tends to 0, 4 to the power x by x, limit x tends to 0, 3 to the power x by x. So 1 minus cos x by x square. So all are standard limit. So what is the value? Minus 3. This is log 4. This is log 3. And this is half. So minus 6 log 4 into log 3. Or minus 12 log 2 log 3. So this is value of the limit. Very simple problem. So standard limit log 4, obviously base is e. If it is not given, base is e. Now consider problem number 17. So there is a well-known result of some multiple angle. So look, cos angles are double. This angle is double of previous. So try to recall the relation. So you know sin x equals to 2 sin x by 2 cos x by 2. So there is no sign here. So 2 cos x by 2 unchanged. Again we put this formula. X by 2 square cos x by 2 square. So 2 into 2 4. So 2 square cos x by 2 cos x by 2 square. Again this formula. 2 cos x by 2 cube sin x by 2 cube. So 2 to the power cube cos x by 2 cos x by 2 square cos x by 2 cube sin x by 2 to the power 3. So proceeding in this way, if we expand sign factor, finally we get, for 3 this is 2 to the power 3, 2 to the power n, cos x by 2 cos x by 2 square cos x by 2 cube cos x by 2 to the power n sin x by 2 to the power n. For 3, look, this argument same. So this is well known result. Sin x equals to. Now here result is from this to this. So what is the value? Sin x by 2 to the power n sin x by 2 to the power n equals to cos x by 2 cos x by 2 square cos x by 2 to the power n. So this result, this is result of trigonometry. Now it is very simple. So limit n tends to infinity. So what is the value? Sin x by 2 to the power n sin x by 2 to the power n. Now limit depends on n only. So we can write it as sin x outside limit n tends to infinity 1 by 2 to the power n sin x by 2 to the power n. So let 1 by 2 to the power n equals to y. As n tends to infinity, y tends to 0. because half to the power very large number. So what is the limit? Limit sin x unchanged, limit y tends to 0, sin x into y, 1 by 2 to the power n, this is y. So sin x unchanged, limit y tends to 0, xy by sin xy, now it is balanced by 1 by x. So sin x into 1 by x. So what is the value of the limit? Sin x by x. So answer is sin x by x. So this result to be recorded if possible. Next, last one. So x tends to minus 1. Cos inverse minus 1. Look, cos inverse minus 1 equals to cos inverse cos pi. So this is pi, you know. So root pi 0 and this is 0. So it is 0 by 0 form. So we can use L'Hospital at the beginning or you can rationalize it. So rationalize first. So pi minus cos inverse, this is minus x I think. Pi minus, no, oh this one is minus 1, so this is x. Here it is minus 1. So pi minus cos inverse x. And this is root over x plus 1. 1 by root pi plus cos inverse x. So rationalizing factor, we write it alone. So if it is problem of computation, you write direct value. No need of showing this step. So pi minus cos inverse x, x plus 1. So this is pi. So 1 by root pi plus root pi. So I have already discussed this is pi, cos inverse minus 1. This is pi. Limit x tends to minus 1. So cos inverse x. Minus is absorbed. And this is obviously within root over. So 1 by 2 root x. 1 by 2 root x. So finally 1 by 2 into root over pi. Limit x tends to minus 1. 2 root x. 2 root x. This is not x, x plus 1. X plus 1. And this is 1 plus x. 1 minus x. So this cancel out. Now it is defined. So 1 by root pi. And this is minus 1, this is root 2. So 1 by root over 2y. This is answer. So look it again, rationalizing to avoid derivative of root over. So rationalizing factor, this creates no problem, keep it separate, put the values, then use L'Hospital rule because it is 0 by 0 form. So through this video, I have solved some important problem of limit. These problems are important for JEE Main and Wbjee. So you practice rest of the problem from description box. Thank you.